Hello. I'm going to run a Elmer simulation job in the schema web interface, which is connected to a WES and task execution services. No? First, I log in with my account, go to workflows, and here I have the Elmer workflow. It's still in beta 0.08. And go there, here, and just select output directory to get the results, and here is the case. We can see the case later, but let's launch the simulation because it takes 10 minutes to run, under 10 minutes. As you can see in the left side, this is the test. Now, test stands for Task Execution Service. So it's basically what it runs the actual simulation, and uses Kubernetes. Initially, we only have the test KPI pod running, which is the one that controls the API in the sense of receiving the request and them executing them. No? What it does, it creates a pod called task random number, and then another random number. The first one is the task number, and the second one is the pod number. Never mind. That controls the whole process. First, creating an inputs filter, which is going to retrieve from a schema the state or eigen mode.zip file. It's still in the container creating, and after that, it will be internal to the task, in this case to the namespace of Kubernetes, and we'll put it in a volume. After this is finished, it will create a task number -x, x for execution, which would be what it will be executing the job itself. So meanwhile this is running, we can take a look to the state or eigen mode file. Okay, so this is a normal Elmer case file, basically, inside a zip file. You can see at the beginning the mesh files, the case.zip, etc., etc. The only thing we had to add is a file called job.sh. In this case, the simulation will take the zip file and tip it, and then look for the file called job.sh and execute it. This file will do the simulation, we will check it later, and will basically, after the simulation is over, take whatever is the results that want to be returned to the user and put it in a file called results.zip. That's what this workflow is waiting for. Meanwhile I was talking, this execution started. Now it will take approximately 9-10 minutes. So if I'm not mistaken, here is the file. And this is a normal bash file. No, it sets some variables and then executes 3 commands: the Elmer grid command, the Elmer F90 command, and the MPI run command, which is the command that will do the actual simulation. And afterwards, you see here there is a zip result.zip to create a zip file from all the results folder. The beauty of this system is that a user can run any command they want in this job.sh. Then this is run inside a container, which is isolated from the rest of the system. So in a way, you're giving the freedom of running whatever, doing any kind of calculation or anything you may need, but at the same time you are contained inside a container that doesn't let you either harm others or be harmed by others, and sharing the same hardware. This is still running. It will take a couple of minutes more. We can take a look now to the data folder. This is empty. This is where the output, we selected the output to be. And if we go to my personal space, here you can see that we uploaded already the stator eigenmode zip, but nothing else. We go to job history, you will see that after a lot of tests, a couple of failures, we managed to have a complete job. And it took a little bit less than 10 minutes. So it started at 33 and finished at 41. These are UTC dates. So here is actually almost 9 in the morning, not 5 in the morning. Coming back to the job history, we can see here, this is the one we are running in the other tab. We can basically reattach to it. It will query the API on real time, which is very interesting. And also coming back to job history, we can rerun any of these jobs that failed or the one that completed. Let's now take a look to the actual containers. This is the workflow that we created and installed already in schema. It's very simple. It's written in CWL. This is the actual job that runs the simulation. And this basically specifying the image. This is the image I created, taking an Elmer image as a base and just adding an entry point that will do the unzip and the run of the job. No, it's a very simple script. I can show you later. It has an input of a file, which is the zip file of the stator eigenmode in our demonstration case. This is still running, but the W, that stands for wait, it's timeout. And then the results has to be a file called results.zip. Base command is the entry point of this container, which we can check out. It is also in GitHub. So here we don't even need to see the files because they're all in the README. They're so small. So it just takes this Elmer Fem image that was created from the Elmer official repository in GitHub. Oh, the execution just finished, and now it's running the outputs filter, which is the same as the inputs filter, but taking the results back to Wes that will return it to schema. You see here the entry point, and as the README already states, this is just a beta, so it works, but it should be improved a little bit because it just checks that a file name was provided, so this variable is not empty, -c, -set, it stands for 0, and then that this is really a file. Otherwise it protests and gives some kind of message for us to notice. Then it just does the unzip, which will unzip all the files in the current working directory, and then with a bit rudimentary find command, we just try to find a file called job.sh and execute it. Yes, the filters have finished. has finished successfully, and also means that the task pod that was creating all these other free pods has also finished. We can come back here and show that it has completed in 9 minutes and 14 seconds. This includes not only the simulation time, but also the time of creating the pods. The bigger is the simulation, this overhead of creating the pods will be lower. So if we go to data, we can see here in output that the results are here. And we can just download it from here. Let's open it. And we see it's a results directory, and here there are VTU files, which can be analyzed by the Elmer tool in a local computer.